So this second page here, we're going to start taking a look at the second part of the chapter, the vertical and horizontal asymptotes. So the first thing we have to do is factor, and we have to factor the numerator and the denominator. So let's see. 2x squared negative 3x 4. So 2 times 4 is negative 8. So is there anything that multiplies to negative 8 and adds to 3? So no, so the top part isn't factorable. So the bottom part, let's see, this factors into x minus 5, x plus 1. So when we think about the verticals, what makes a 0 in our denominator? So we have x equals 5 and x equals negative 1. And for that horizontal, we look at those powers. So they're the same power, the big over big. So those coefficients would be y equals 2 over 1, which would be 2. So the second one says find the whole. So again, we have to do some factoring here. So let's see. 2x squared, 5x negative 3, so negative 6 and adds to 5. Well, so this one's factorable. We got 6x negative 1x, so 2x and x plus 3 minus 1. So this top part, x plus 3, 2x minus 1. Well, then we have to factor the denominator. So we got 3x squared, 10x and 3. So 3 times 3 is 9. So what multiplies to 9 and adds to 10? 9x and 1x. So this would be 3x times x plus 3 plus 1. So it divides into x plus 3, factors into 3x plus 1. So this factor reduces out, so that's our whole. So our whole would be at x equals negative 3. So what is our domain? So what possible x values? Well, if we factor this, it factors into x, let's see, plus 4, x minus 3. So we have two vertical asymptotes. So our domain is all reals, except x cannot be negative 4, and x cannot be positive 3. So we have to find the zeros and the y-intercepts. So zeros, so our, let's see, our x-intercepts and y-intercepts. So x comma 0. So when does 0 equal x squared minus 5x plus 14 divided by 2x plus 1? Well, we can multiply by 2x plus 1. So when does 0 equal x squared minus 5x plus 14? So this factors into x plus 7. Nope, not x plus 7. It's got to be minus 7. Minus 7 and x plus 2. So there must be zeros at x equals 7 and x equals negative 2. And then for our y-intercept, 0 comma y. So if we plug in zeros, 0 squared, 5 times 0 minus 14 divided by 2 times 0 minus 1. So this would be negative 14 over negative 1, so positive 14. It says graph f, g of f of x, label the asymptotes and y-intercepts. So g of f of x, so this is going into our g function, so 1 over x plus 3 plus 2. Well, let's see, what do we know about this? Plus 3 moves it our asymptote because this is a shift on the parent function. up to, and let's see, what would our y-intercept be? So our y-intercept, we plug in 0, so 1 over 0 plus 3 plus 2, so 1/3 plus 2. So right here, 2 1/3. So that means our swoop must be here and here. So our domain, all reals, but x cannot be -3. And our range, all reals, except y cannot be 2. So number 15, we have to graph it. So this is kind of the whole thing that we were doing at the end. So let's factor this. Whoops. So it factors into x minus 4, x plus 3, divided by, let's see, this would be x minus 4, x plus 2. So it reduces down to x plus 3, x minus 2. So if we were to graph this, our vertical asymptote would be at x equals -2. Nope, not -2. Let's switch that to +2. 1, 2. When we look at our degrees here for our horizontal, they're the same. So it's at y equals 1. Let's see. Our x-intercept. So 0 equals x plus 3 over x minus 2. So that means 0 must equal x plus 3. So it's at x equals -3. 1, 2, -3. Our y-intercept, plug in 0 for x, and I'm just going to go to that original one, 0, 0, 0, 0, so -12 over 8, so 12/8, 6/4, so +3 over 2, so 1.5. So we know our swoops must be here and here, but we had a hole right here at x equals 4. So we can go 1, 2, 3, 4, go up to our graph, and we'll put a hole there. So here's another graphing one. We have to label and find everything. So we have x minus 3 divided by x minus 3, x plus 3. So it simplifies to 1 over x plus 3. So once again, we got a hole here. So graphing it, our vertical asymptote would be at x equals -3. 1, 2, 3. Dash that in. Our horizontal asymptote, well, let's see. When we look at our degrees here, small over big, so it's automatically at y equals 0. Let's see our x-intercept. So when does 0 equal 1 over x plus 3? So does 0 ever equal that numerator? That's not possible, so there's none. And that would make sense. We have a asymptote there. And then our y-intercept, when we plug in 0, so 1 over 0 plus 3, so it's at 1/3, which would be right here. So we know here is one of the swoops. Whoops, I missed that point there. Another one would be in this quadrant. And we had a hole at +3, so 1, 2, 3, and we can circle the hole there.